Alright, so today we're going to solve this trigonometric problem. It says that cosine of the angle 3x equals -1, and we want to solve for x within a constrained domain from 0 to 2 pi. Now, 2 pi shows us that we're looking at angle measurements in terms of radians, so the first thing we want to do is make a substitution that will make our lives easier, which is always happy. So we're going to substitute theta for 3x. So we'll say that theta is 3x. This is a substitution. And now we can rewrite our original problem. The cosine of theta equals -1. And we know that on a unit circle, the cosine of an angle is the x-coordinate of any point on the circle. And so the only time on a unit circle where the radius is 1, the only time where the x value of a coordinate is going to be -1 is over here, where x has gone -1, the radius. So the angle that gets us there is pi radians. So we can say that the angle theta equals pi radians. So now we have a solution to this in terms of theta, but we need a solution in terms of x, so we're going to take our substitution and replace theta with 3x. X equals pi, so x, if we divide by 3, we get x equals pi divided by 3. Alright, so that should be a solution. We need to check our domain. We know that if we put pi thirds into our original function, that pi thirds times 3 is pi, and that the cosine of pi is -1, so we know that that's a solution to this, but we have to think about our domain. Pi thirds is positive, so it's greater than 0. Pi thirds is less than 2 pi, so this is one solution to our problem, but you know that a trigonometric function like cosine has a period, which means that there may be more answers than this first one that we found. Now, what we're going to do is think about the period of our original function. So we know the period of the parent function cosine of x, the period of cosine x is 2 pi, and we'll make a graph of that. So we have our y-axis here, we have our x-axis here, and we know that the range of a cosine function, it can't exceed +1, and it can't go below -1, so we'll have a range from 1 to -1, and we know our domain for one period of cosine x is 2 pi. We also know that the domain we're interested in solving this problem is from 0 to 2 pi, so from 0 we'll say to 2 pi here. So pi is halfway from 0 to 2 pi. pi halves, 3 pi halves, and we know that the parent function at 0 degrees, the x-coordinate is 1. Now our parent function is cosine of x equals y. So when we put 0 into cosine of x, it gives us the answer to that is the x-coordinate on our unit circle, but the answer to this we said is our y value, so we're graphing the x-coordinate on the unit circle as our y value on this graph. So at 0, cosine is 1. That should be review at this point. At pi halves radians, cosine gives an x value of 0, which we're going to put as our y value on this graph, 0. Pi radians brings us to here where we're at -1. 3 pi halves brings us back to here where we're at 0. And 2 pi radians brings us all the way back to where we started, which was at 1. So our parent function looks like this. Now, that's one period. So we need to think about what it's going to mean for our angle to be multiplied by 3. It changes the period, it compresses it, so that this is going to occur 3 times as often. Cosine of 3x means I'm going to have my period occur 3 times as often. So, the period for cosine of 3x is going to equal the period of the parent function, 2 pi, divided by the coefficient on the x term, which is 3. So, at 2/3 pi, which is about here, and at 4/3 pi, we're going to have, well, we'll look at this one first. So 2/3 pi, if we put that value in for x in our original function here, 3 times 2/3 pi is 2 pi. Well, 2 pi, the cosine of 2 pi is +1. If we put 4/3 pi in, we get 4/3 times 3 is 4 pi. And so 4 pi is once around our circle, twice around our circle, and we're back to the same value as 2 pi, which is 1. Now, at 1/3 pi, here, 1/3 pi times 3 is pi, so cosine of pi brings us to here on the unit circle, and so we know that our value is -1. So we see that we have one period from 0 to 2/3 pi, like this. And that's going to happen again, well, let's think about pi. At 3 pi, we go 1 pi, 2 pi, 3 pi, and we see that we're at -1 down here. So it's going to go dip down and back up for a second full period. And again, we're going to dip down and back up for a third period. Now, what we're looking for is an x value that makes cosine of 3x be -1. Well, we see that that happens at x equals pi thirds, that's here. And then we're going to see it happen every time we go through another period. We're going to hit that value of -1 again. Once, twice more. So we have 1, 2, 3. So if we take our original solution and we add our period to it, we'll get to another solution. And if we add a period to that, we'll get to a third solution. So we can say that x equals pi thirds. It also equals pi thirds plus 2 pi thirds. That's a full pi. We see that on the graph right here. And we can see that if we add another period, we'll get to a third value for x. So pi plus 2/3 pi is 5 pi thirds. Now, if we go another period from this, we're going to add 2 more thirds of pi. Well, 1/3 of pi gets us to 2 pi, and another third is going to take us past 2 pi, and that's outside of our constrained domain. We only want solutions for x that are above 0, here, 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 and below 2 pi. So, this is our final solution in that constrained domain. And we're done. Thanks for listening.